Hello and welcome back to a new topic in C programming. In this lecture we are going to talk about functions. So it's a new interesting topic to learn in C programming to organize your code, and we will see how we can do functions, which is a new technique for programming in C programming language. So let's start. The outline of the lecture will be as follows. So we will have introduction for functions, what's the meaning of functions, and what is the importance of those functions, and then we will see how we can create our own functions and how we can use these functions to organize our code. Also, we will see different type of functions for passing some simple data and functions to pass arrays or strings. So let's start. Functions is a self-contained unit of programming code which we use to do some specific task. So let's see what, so for example, maybe you used before printf and scanf, size of, rand, srand, get character, get a put character. Those are functions. So this one is a function, and how we know this is a function, we have those round brackets here. Those round brackets mean this is a function, okay? And usually the function do specific job, like for example printf is just print on the screen, scanf read from the keyboard, size of will check the size of the variable you pass to here, okay, you put here. And also rand, this is to create random number. And also put character, this one to read some similar to the job of the scanf. Put character is similar to the job of printf, but this one just for one character, this one just for one character. Power is to calculate the power of a number. So for example 2 to the power 3, okay, this kind of it will calculate this kind of numbers. So we will see how to create our own functions, same like before we just use those functions, but now we will learn how to create our own functions. So the functions are just a small software inside your software. It's a small software inside your software, and this small software will do specific task, okay, specific job. So we will see those functions, how we create them by our like our own functions later in the lecture. But why do we need functions? Those functions are very important to organize your code and also to put a specific job or a specific task in a function and then later use it anywhere in the code easily. So this will be for reusable of some code again and again and again in your code. Okay, so you can, if you have some part of the code you are using a lot, in this case you can put that part of the code inside function, and then later you can call or use this function multiple times in your code. Also, it will be easy for debugging. Check if there is an error or there is a problem in your code. It will be easy if you divide your code to a small parts, we call them functions. But if you put your code all just inside the main function, in this case it will be hard for you for debugging. Okay, and also it's very important to make the main function shorter. So when you create multiple functions, in this case the main function will be simpler. And also it will provide for you, or it will let you avoid repetition. So for example, if some part of the code you are using a lot, in this case you will not write this code many times in the main function. You just put it inside function and then you will use this function multiple times. So in this case it will make you not repeat the same code again and again. We will see some example now in the next slide which will prove for you the importance of the main or of the functions as we will see later. But now before we go to the see the importance of the functions here, let's see how we can create some simple functions, and then we will go further and see a complex example. For example, here we have a max function. this max function receive two numbers, and it will calculate, it will find for you which number is the maximum number. Like, for example, I pass x and y, and it will, the function max will do some job inside. There is some C code inside this max function which will evaluate which one is bigger, and then it will return back for you the number which is bigger. So in this case, this max, this is how we can the function max here. We will have, this one is the input, okay? So we will give some input here, x and y, and then whatever the max calculated will return for me some output. That output is a number because we pass two numbers here. The output will be a number. The number, output number will be here. This is, we say here integer. This is the output number. So this is what mainly the function will do. But how we can do this one in C programming, this is what we are going to see next. Okay, so before we let's see the example without functions, and then we will see functions. So here, a simple example. In this main function, we will have integer ii, and there is a string here. This is a string. And then I will ask the user, please enter your name. And then it will ask for a string from the user. And this string name will go to name, okay? Now here there is no and. Why there is no and? Because name here is array, okay? So we don't put and. But if this one is a variable, just normal variable like I, in this case we put and here. And then we read the scan, we read the string. Then what we do here, we make a loop. In this loop we say start from I equals 0 to I less than 20. Okay, from 0 to less than 20, that means 20 steps. Each time I will be plus plus, that means increase 1. So in this case, this loop will repeat. How many times this loop will repeat? This loop will repeat or will execute. This loop will execute the code inside the loop. There is just one line inside the loop. This line of code will be executed 20 times. Okay, so this one 20 times. Why? Because starting from 0 to 20, every time I will increase 1. Every time increase 1, that means this line of code will be executed 20 times. What this line is doing is just doing dash. So it will do something like this, dash, 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 20 dash. Okay, and then after that, we will print a new line. So it will be new line, and then it will print your name is, and then it will read some string, and this is string from name array, which we read from the keyboard, and will tell your name here. And then after that, we will make a loop again one more time, and this time it will be 10 times, it's 10 steps. So it will be 10 times here. Why 10 times? Because we have from 0 to less than 10, I increase plus, so it will execute this one 10 times. So here is it. It will be this one here it's 20 times. So if this one here is 20, then it will be the same thing. Okay? And then it will print a new line. So this is the software. But what we saw here, what we noticed, that this code is repeated again, same code. Sorry. Okay, here is it. This code here is repeated twice. So because this one is repeated twice, I can take this code and put it inside function, and then I will replace this code by the name of the function. So like this, we will just have dash function here, and this dash function is of I'm calling a function, and this function will be what? The code we copy, this code. So this code will be here in the dash function. Okay, so let's see how we can do this one. Okay, so we will do this one in Visual Studio. You can create, so here is the example. In this example, we'll say, please enter your name, read the scan, and then we will print here this one 20 times and this one 20 times. So here is it. So I will print, by the way, this one, if it's optional, but you can put this one here like this, okay, and then after that, this one, okay, like this. So this is the code, okay, if you want. And then after that, so this line of code and this lines of codes are repeated, okay? So we can modify and make this one works in easy way. So how we can do this one? We just create some dash function. So we will go here before the main function and create dash. Okay, so we can call it any name you want. So we say this dash function has no return value, does not return anything. This dash function just print on the screen some dash line. Okay, so in this dash function, and we don't forget about this one, round brackets. So those round brackets are very important. So here is so this is the name of the function, and this is the retain value of the function. This function does not retain anything. This is just to print on the screen some dash line, okay? And now inside here, we will put the code which is repeated. The code repeated is this part, you see? This part is repeated, and because look here, this one exactly same this one, okay? It's repeated. So why I should repeat this one? So I can Control X, take this one, and then put it here, okay? And then delete it from here, okay? So we will replace this one by dash, okay? So you see here, I'm replacing this one by the function. This one, call the function, okay? I'm calling the function. So this is the dash. Okay, and then this one is the same code. Okay, this is the same code like this one. So I delete this one, okay, again, and then we will put here just dash. Okay, you see the code. So now the main function became compressed and nice. Okay, now let's go to this code. Still, there is error. Why? You see the II here, there is a red. It say, I don't know where is the II, because the II we implemented here, we take it in the main function, take this one from here and put it here. Okay, this is done. So this is II. Now we are done. This one is our function. So we created the function, and in this function it's doing just the dash line. Okay, so we now replace this one by the dash here and replace it by the dash here. Okay, so that's it. So let's see if this one is running. Yeah, here is it. It will ask you, please enter your name. So I will say here, for example, Young J. Okay, so this is your name, and it will say, does not read the space, so it's okay. Your name is Young J. Okay, so here is it, and there is the dash line here. You see, it's working. The dash line here and the dash line here. Okay, so it's working. From where those dash line come? From this one. Okay, so this is the dash and this is the dash. Okay, now maybe let's make this one more nice. So you say, okay, why you put the code before the main function? If I don't put this one before the main function, I put this code after the main function. So I can do that. So I can say, for example, take this code of the dash function and take it out and then put it after the main functions. I can do that. If you do like this, in this case, and run your code. Now, if I run, so let's run here. It will tell you, I don't know what is this dash function. Even the dash function is here, but it will tell you, I don't know. So the compiler of C language does not see the function dash because it's coming after the main function. So how I can tell the compiler of C language that, oh, dash function is there, but it's after the main function? I can do that by putting here something we call it prototype. Prototype is what? So the name, look here, this one, I will copy this one, just copy this one. Here, Control C, copy this one and put it here, Control V and semicolon. That's it. This is, we call it prototype. So this one, we call it prototype. So if you want to put the function after the main function, no problem. So you need to put prototype here. So if you put prototype, now let's run and see if it's working or not. Yes, it works. So if you see here, I will say here, for example, Tamer. Yeah, it works fine, no problem. So again, so what we learn in this example, we learn how to make a function, and this function does not retain any value, and this function is printing dash line. So this repeated code, I just replace it by a single line. And those code, repeated code, I just put them inside a function. And then if we put these dash functions after the main functions, we need to put prototype. But if there is this code, if you put this code before the main function, no need for prototype. Okay, so this is the rule of C programming. Now the question is, how about if I want one line. For example, this dash function may print dash line with a 20 dash character, and here it will print the dash line with 10 dash characters. So I want something similar to this. So let's see. I want here, for example, in this area, I will say, please enter your name. And then after that, I will put here 20. Okay, this is a 20, for example. And then in this one, I will print just 10. I want 10. Okay, so I want like this. Can I do that? Yes, you can do that. So how? Let's see. We can here, so do like this. So how about we say here in this dash function, in the first dash, I will print 20 characters. And in this one, after that your name is, I will print 10 characters. So in this case, you are passing here some value, and you say you use this value to print, 20 characters of dash, and use this number to print 10 characters of dash. How the dash functions will use this one? So the dash functions I can put here, for example, I say here integer count, okay, count, for example, and this count is receiving, so the 20, this one, we call this one actual parameter. So this one, the actual value 20 will go to something we call it formal parameter of the function. So the count will be here. So the 20 will go to this one. Okay. And then this one will go where? I will say this one, go here. Count. You see this one? Now it's became dynamic. Whatever the value here is a 20, this one will be 20. If this one is 10, this one will be 10. So the loop will be 10 characters. So this one now became more dynamic, okay? So this parameter will go here, okay? So now this 20 will go here as a 20, and then this loop will run 20 steps. This 10 will go here, 10, and then this one will loop 10 times. Okay, but because we change the dash function, we call this one input. We call this one input for the function. So this one is the input, and this one is the output. This one input, this one output. So the input is a 20, and this input is 10. Okay, so this 20, but now because we change the function here, signature of the function, we call this one signature of the function. So the function now became receiving one value. We need to change this one also. We can say here, we can do like this. We just copy, okay? Copy, Control C, and then paste here, Control V. It's okay. Now it's fine. So you must have the prototype exactly same like the function signature. So if the prototype here, same like this one. So if you change anything here, you must change this one here. Okay. So now let's see what will happen, because now we will have dash. After this one, we'll have dash 20, and here we have dash 10. So let's run. Let's make this one small so you can see. And then I will have here. Okay. So for example, here we say John. Okay. So click. Let's go up a little bit. You see, it's working. So here there is a 20-1, and here there is a 10 of this dash. Okay. So we make it dynamic. So it's received the function dash behave based on the input parameter, or based on this actual parameter. This one we call it actual parameter. So this actual parameter go to the formal parameter. This one we call it formal parameter. Okay, so we learned several names now. So we learned this one is prototype. We learned that this one is actual parameter. This one is formal parameter. This one is the name of the function. This one is the retained value of the function. Okay, so let's back to our slides and continue. Okay, so this is prototype, and this is the call of the function. You call the function here, and how this one will run. This one will run like this. So first you will print, and then you will define the function, and then you will print this one, and then you will scan, and then after that you will jump to the dash function. He will jump to the dash function, execute the code of the dash functions, and then finish. After you finish the dash function, he will continue from here. And then again, dash one more time. He will jump to the dash, execute the code of the dash, and then return back. Maybe I can print after this one, print F. And then I will print here, for example, finished. Okay, so like this. Maybe I will put here slash. Okay, so we can run this one. Okay, came, and you see it's finished. Okay, so this is how this one is working. Okay, I hope this example is clear, and this is very important to understand functions. So this is why I spent some time here. Okay, this is just explanation for what I already mentioned before. So function declaration or function name is dash, and dash has no arguments here because no argument means no input data, no input. And what's the meaning of void here? Void means this function does not retain any value, no output for this function. Void here means no output for this function. Okay, and now when you call the function, this is we call calling of the function. That means execute. I want to execute the function. We call this one calling. Usually the call of the function is used just the name of the function with the brackets. So this is the call of the function. Okay. And the function definition is this one. So this is the, what is the definition of the function? What is this function contain? Or what is this function is doing? Okay. Now let's go to another example. So in this example, just as you see, we see several examples until everything will be clear for you. So in this example, we will have a function, and this function do summation, sum. So sum from I equal 1 to I equal the count I want. Okay, so for example, I want to do summation from okay, for example, 1, 2, 3, 4, 5. So I will make summation of this one, so it will be 1, okay, 1 plus 2 plus 3 plus 4 plus 5. Okay, so this is mean summation from 1 of I from 1 to 5. So it will be like this. Okay, this is the meaning of this one. So this summation function receive input I. It will receive what is I, how much value you want to sum from where to where. So I want to sum from 1 to 7, or I want to sum from 1 to 10. Okay, so this is, and then the result of this one, is the output. So what is the value of this one is the output, okay, or return value, return value, okay, or we call this one the output. Okay, so this function receives some input. The input is from where to where you want to sum. Okay, you want to, sorry, it will want to, this is the input, the 5 here. I want to sum from 1 to 5. I want to sum from 1 to 100. Okay, so this one is the input. 5 here is the input. Okay, so I have one input that from where to where, this is the input, and the output is the result, or result of the summation. So let's see here how we can implement this one. So here I define sum retains some value. The result will be a return value as a number, because as you see, the summation of the numbers will be number. So this number will be return value as a number. And also sum receives some input. This one is the input here. This one is the input. Okay. So the input here is from where to where. I want to sum from 1 to 5 or to 10 or to 100, or so this is the input, or the integer number here, or the input. Okay, so and this one is the result or the output. Okay, so this is the output. Now this sum function, let's see, in the main function I have integer limit, start from 0, output is 0. Okay, and then I read the limit from the user. I say, tell me from where to where you want to sum. You want to sum from 1 to where? From 1 to where? From 1 to where you want to sum. So give me the number, limit. Give me the limit. So when you give me the limit, okay, now the limit, say for example 5. So this 5 limit will go here to the sum. Now the sum give limit as a 5. So 5 come here as 5 here. So the count now became 5. Okay, and then sum generates some output. This output will go to the out variable. So sum give the output to the out variable. So the out variable will receive the result of the sum. Okay, so the return value will go to output. How? Using the equal sign, or we call this one assignment sign. Okay, so and then after that I will print limit and out. Okay, so I will say the sum from 1 to the limit equal this one, the output or the out. Okay, now let's see the sum. What is the sum function is doing? The sum function receive the count or the limit. The limit will be received as a count here. You say, okay, why you don't put the same name? It's okay, it's up to you. You can put the same name or different name, so you are free. But whatever you pass, when you call the function limit here, when you pass limit here, whatever you pass, it will go to the count here, okay? You pass variable limit, that value of the variable limit will go to the count, okay? And then the count now equal 5. For assume I put limit equal 5. So the count equal 5. So what will happen here? I will make a loop start from 1 to 5. From 1 to 5. So from 1 to 5, every time the loop I will increase 1. So first time I equal 1. Second time in the second loop I equal 2. Third loop I equal 3. Fourth loop will be equal 4. I in the fifth loop will be equal 5. After that, stop. Because now I became 5. 5 equal or equal to the 5, the count, and in this case, stop. So every time do what? Make a result variable, and that result variable equal what? The result variable here, this, what's the meaning of this one? This one means result, okay, result equal the old result plus II, the new value of II. So the first time result equal 0 plus 1. First time the result equals 0. Look here, result equals 0. 0 plus 1. Next loop it will be a new result equal 1, so it will be 1 plus 2. And then next time it will be 3 plus 3, and then and so on. So it will count this one, the total results. And then after that, oh, here is the new things we learn here. How to give the output of the function, the result of the function. We say retain result. When you return result, this return result will go from sum to the out. Okay, it will go from sum to out. So this is the retain value. It is very important. This one to retain or to return back the result of the function. So this one, result is integer. Look here, result is integer. So the return value will be integer here. Okay, return value will be integer. So retain result. Okay, and then it will return result to the out here. Okay, so let's do this one together. So I will have here, so let's see here, I will delete this one and then okay, so here is it. I will define some, okay, I will say here integer sum. I'm writing this one by myself just to let you feel what I'm doing, okay? So here is the integer, for example, count, okay? And this is the prototype of the sum. So the sum receives some input value, okay? Or let's call this one, yeah, it's count. That means the limit of the sum. And it will retain some value sum. And then here I would say, for example, integer limit. And also there will be output, yeah, integer output. Okay, and then out. So there are two variable. And then I will say here, for example, print f, and then I will print here, say, okay, please I will change that just when I'm writing. I can't remember the code, so I will do similar. Okay, but it's same, almost same. Insert, for example, insert the limit of the summation, for example, and then I will ask here for some. Okay, please insert, and then okay, and then after that I will do some scanf. Okay, I will read some. I will read some digits. Okay, so I will say here modulo D, read some digit, and that digit will be, because it's single value, I will say this one limit. Okay, so here we go, and yeah, I read the limit now, and then after that I will call. I would say out value. The out receive the value from where? Receive this one from the sum. Sum receive input, or sum get some input. This input is what? Limit. Okay, so the limit will be go here as input to the sum. So I'm calling the sum function, and then this one will go to the out. The result of the sum will go to the, or the output of the sum will go to the out variable. Okay, and then after that I will say print, for example. Okay, print f, and then I will say here, for example, okay, the sum from, okay, sum from 1 to limit, for example, okay, modulo D, that means the limit is or equal another limit, okay, another digits, okay, digits. So there are two digits. First digit will be limit, so, and the second digit will be out, okay. Yeah, so that's it. This is the software. Now let's create the sum function. The sum function will be after the main. This is why I put the prototype up there. So I will say here, same thing. I will say integer sum, and then I will say here, for example, integer count. Okay, this is the sum function. Okay, and the sum functions do very simple things. So it will just create some integer I. Okay, this is the counter. Okay, and also it has some result, which has the result of the summation. Okay, then after that I will make for loop. Okay, let's do for loop, and in this for loop we will do it like this. Okay, in the for loop we'll say start from I equals 0, from I equals 0 to I less than count, less than count. Okay, but this one we will sum from 1 to the number, so starting from 1. So this is will be starting from 1 to until count equal less than or equal count. Okay, I plus plus, that means increase I every time. Okay, so what you will do here is say result. Okay, result. Okay, plus equal I. It's like this. Okay, then after that you will do what? You just retain the results. Okay, you already have the results, so retain the results. Okay, that's it, done. Let's see if this software is working fine. Okay. You need to initialize result. This one you should initialize it to equal 0. Okay, and then maybe also I equals 0. So this is just initialization to make the software, to be sure that the software will run okay without any problem. So here is it. Please insert some number. Sorry. Okay, this one will be, for example, 5. Okay, so it will tell you here, let's see the output. The sum from 1 to 5 equal 15. Yes, that's correct. Okay, so this is how this one is working. Okay, very simple. Okay, so this is how we can create, now what we learned from this example, how to give some input for the functions. So this is what we learned. Now, another interesting things, maybe you will note, some of you already notice it, is that in the here, we say, I told you, you just copy this one, and you paste here, and you call this one a prototype. But in the prototype, there is interesting thing. If you can here put the name for the variable or for the input, or you just delete it, it's okay, no problem. But here, no, you cannot do that. Only in the prototype. In the prototype, you can put the name, like we say like whatever you name here, or you delete it. It's not that important. This one just to tell the compiler, oh, please, just go down and check. There is a function, receive some input, and generate some output. That's it. This is what we want to tell the compiler. So this prototype just to tell the compiler there is a function sum. There is a function sum. Please go and check it. Okay, that's it. This is the main goal of this prototype. Okay, so if you put name here, if you don't put name, it's not important. But here, if you don't put name, it's a big problem. Okay, so you must put name here for the input. Here, it's not big problem. It's okay, because this one just to inform the compiler. I hope this one is clear and not confusing. So if you want to put name here, if you don't want to put name, it's up to you. Okay, so this is just summary for what I told you here before. Sum receive some input and there is output. Okay, and the input we call them argument. We call them arguments. So here is the count is an argument. Okay, so just a name. So if you heard later I'd say argument, some get like this argument count, you know what's the argument. Argument means the input. Okay, for the function. Or we call them also not argument, we call them formal arguments. So in here we call this one formal arguments, and then when you call the function sum, the values you give to the count, we call this one actual arguments. So for example here, let's go back to the example here. Here we call this one, so let's see. Here, for example, this one is formal argument. So this one, formal, okay, formal arguments. Okay, and here when you call the function sum, this one here, limit, we call this one actual arguments. Okay, we call this one actual argument. So actual argument is limit. Limit here is actual arguments, and this one here we call this one formal arguments. So actual argument give its value to the formal arguments usually. So sum, when you call sum, the actual argument value go to the formal argument value. Okay, hope this one is clear. What's the formal argument and what is the actual argument? Here is it. So some other things here, you can say sum, and then you can give here some rand. Rand, that means call another function rand and generate some output, and that output give as input to the sum. Okay, so this is here, and sum here you can put in the sum as actual argument. You can say 17 minus x. Okay, this is expression. Or you give another function power, and then this power. So how this one is working? So for example, when you call sum, okay, let's do this one together. I can say here, for example, limit is equal limit plus 2, for example, like this. So whatever limit plus 2, this one will be as value, single value, and this value will go to count. So let's run this one, and whatever limit. So for example, we say limit equal 3. Okay, 3 plus 2 equal 5. So it will be count from 3, okay, from 1 to 3. So this is the limit 3, but it will say this is 15. The output is 15. Why 15? Because this one will print the limit and this one will print the output. Output is, or out is 15. So that means from 0 to 5. Okay, so maybe we can put this one plus 2, for example, like this. It will be more nice to read. Okay, so for example, if I put the 3 here, okay, it's from 3 to plus 2 is equal 15. Okay, so this is, you can do that. Also, you can put here, for example, another function. So say power, for example, power, and then in this power you give, like, for example, 2 to the power 3. Okay, to the power 3. So here, this power is another function. This function calculates 2 to the power 3. 2 to the power 3 will be value. That value will go to the as input to the count. Okay, so for example here, okay, let's make it simple. Okay, 2 to the power 2, it means 4, and 4, that means this one will be 4. So let's see if this one is working fine without any problem. Okay, so here he's asking me for some limit. Okay, whatever, but he's calculating power. So power 0 to the power 2. This one is problem. So let's see. Yeah, I think this one needs some library to include this one. Okay, just this is working fine, no problem, but only need to include math library. Math library, if you include math library, this one will be 2 to the power 2 equal 4. So that means sum from 1 to 4. Sum from 1 to 4. And let's see what is the summation. So if I run this one, I say here, anything, this is will not used, not the sum will be 10. From 1 to 4, summation equal 10. So this is if you can paste the power. So the power will calculate the power and it will return back. So this one is a function, return value, output. The output will be the result of 2 to the power 2. 2 to the power 2 will be equal 4. 4 will be as input for the sum. Input for the sum. And then that 4 will go here as 4. The count equal 4. So you can do that. You can call another function and the output of the function will go as input for the next function sum. Okay, that's okay, no problem, you can do that. Okay, also random number. This is just random number. This is how to generate random number and then pass it. So you can say random number here and let's run. Hopefully this will generate some random value. Yeah, you see, this is random, we don't know. So if you want to print the random number, okay, let's see. I can say the sum. Okay, let's see. Okay, the sum from 1 to, and then another random number 2, and then I will say here, okay, I will put random value inside limit. So I will say, okay, limit equal random value. Okay, so whatever this random value. Okay, so random value, this function rand will generate some random value and this random value go to limit. Okay, so forget about scanf now and forget about this one. So we will just read some value random to the limit and then I will say here limit. Okay, the random value will go to limit. Okay, and then I will say here the sum from 1 to d equal modular d. Okay, another d. Okay, so and then I will say here limit. Okay, so we have two things. So let's see what this one will. It will just random value. We don't know what is this random. Okay, it's 41. Okay, next time if you run this software, next time it will be different value. You see, 41. Okay, and then run again. Oh, it's keeping 41. Maybe if you want this one to be updated, so you say strand. Okay, let's see. Oh, you see, it's different number. It's a random number. Okay, so this is how you can generate some random numbers if you want to use these random numbers later. Okay, so let's continue. Let's back. So we can pass here some. Here is it. You saw random number modular 11. The result of this one will be as input for the sum. Okay, I hope this one is clear. Here is another function, another example, but this example with not single argument, two arguments. So look here, there is a function poly, and this one receives one argument A, and there is another argument B. Okay, there are two arguments here. Okay, so two arguments. This is the difference in this example. What this one will do, this one will calculate R, so this one, it will calculate from 1 to n, calculate R, some value to the power I. So I change every time and R is constant, and it will start from 1 to n, whatever n, okay? So here we will pass R, the constant value R, okay? And we will have one value R and then one value n. So we pass this one to the function and the function will calculate this one. Okay, so let's see. I will say R is equal 0, out is equal 0, and then I will say here this is double, by the way, it's double value. So you put dot here. Don't forget the dot, you mean double. Okay, and say enter a double number, and this double number will be R value. Okay, so this one mean long float mean double. Long float mean double. So pass long float, and this is R, and then pass this R to here. So the function pass to this one R, and then pass also n. N is already constant 10. Okay, n is constant 10, so 10 will pass here. Okay, that's good. Then after that, the result of the calculation, so these results will be calculated by the function, because poly will retain some output here. Here is it. The output will be some double. So this double means this one. Okay, this one. So this is the output, this one, the double. And now let's calculate. So this R will go to here, from the actual parameter to the formal parameter, and this n will go here. Okay, that's good. And then it will do what? It will say start from I, make a loop, and then every time you will calculate power. Look here, because this one is a power, R to the power II. So R to the power II, every time this one sum with the previous result. Okay, sum with the previous result. Start from 1 to n. Start from 1 to n. Here is it. Start from 1 to n. N is this one, n. Okay, start from 1 to n. Okay, you can put this one n small letter. Sorry, this one should be n small letter. But n small letter is equal to the n capital letter, because n capital letter go to the n small letter. Okay, so this is here, and this is will calculate the power. So let's see if this one is working fine or not for a simple example. So by the way, for the power function, don't forget about including math library. Math library is very important. So let me copy this one, and then, because for sake of time, I don't want to spend long time writing code. Okay, so here is it. Okay, I want to be sure the quotations are fine. Yeah, everything is okay, I think. So let's see. Yeah, I think everything is fine. So let's run and see if this one is working okay without any problem. So please enter double number, and I will insert, for example, I will insert simple number. Okay, so I will say, okay, 2. Okay, so this number 2 will be the constant R. R will be 2. Okay, so this one will be the results. The results starting from, this result is what? This result is this one. It will be, this result is 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 until 2 to the power 10. Okay, this one 10. Okay. Okay, so this is will be, the result is this one. Okay. If you want to make this one simple, we can do it simple. For example, 2 to the power 1 plus 2 to the power 2. So this is 4 plus 2 to the power 3. This is 8. 8 plus 4, it will be 12. 12 plus 2, it will be 14. So let's make it until 3. So this n will be 3. So I will change it to 3 to be sure that, just to make some of you might, you can play with this example as you want. So, and also don't forget about change this one to n. It's okay, same. And run again. Okay, so 2 and 14. Yes, 14, this one. Okay, so this one from 2 to the power to 3. So until power 3. Okay, so it's working fine. And this one is, so what we learned from this example, we have learned from this example how to pass two arguments. So for the, by the way, if you don't want to put A and B here, you just delete this one and you delete this one, no problem, it's okay. So this is integer and double. There are two parameters to input. The first input will be R, and the second one will be integer, and then the result will be output poly. So their output. So here is it, R and then N. Okay, so you can copy this one as it is. Copy and put it here, no problem. Control and V here, it's okay. But if you don't want to put some value here in the prototype, that's fine also. Okay, so let's back to our example. So I hope this one is clear. If you have any question, please insert it in the discussion. I will be happy to answer your question. Okay, here's another example, but this example with argument string. So if you want to pass argument string here, so this is a string, as you know, this one is a string. So here, this is a string. Okay, so character A, this one, this is a string. So this one is the name of the function. So str underscore length. So this is the name of the function. Another thing about the name of the function, let's go to our example here. How about if I say here, for example, this is the name of the function. How about if I put here 3? So the function start with number. Can I make the function start with number? No. How about underscore? Can I make the function start with underscore? Yes. So it seems like what? This seems like the name of the function is very similar rule like the variable. How to make a variable. You cannot start by number. Can I start by dollar sign? This one. Yeah, so here, dollar sign, let's make here this one dollar sign, and let's make this one dollar sign. Okay, let's run. Yes, it works. Okay, so if you see here, for example, 3, and it will be this one. So, but can I start by numbers? No. Can I? Here, this will show error. You see, it's error. You should not start by number. Okay, this is important to remember. Can I put underscore? Yes, you can put underscore. You can put the name as you want, okay? But if you change anything in the prototype, change it, make it same for everything, okay? Make it same for everything here. Okay, it will be fine, no problem. Okay, another thing, let's go here to the function. So this function is str length. This is will calculate the strength or the length of the string. So this one, I have a string here. For example, I define some string, 30 character. Then I define len equals 0, and then I will say here, read, please enter your name. So you will insert your name here as a string, and then I will give your name to this function. And this function here, so your name will go here to this function as a string, because this name is a string here. Look here, name is a string. So this name will go to the function here, okay, to this one. So the actual parameter will go, or actual argument will go to the formal argument. So this name will go here. That means A now contain your name, this string contain your name. And then I will make a loop and say start from first character in the array. In this array, start from the first character. If the character is not equal null character, this is the null character, just keep the counter increase. The counter will be increasing. So as you know, when you put here your name timer, for example, automatic, when you scan from the keyboard, your name timer, so if you insert timer, T, for example, T, and then A, and then M, and then E, and then R, timer, automatic, the scanf will insert null character after that. Null character, we call this one null character. So this one automatic will be inserted. So I say here, go character by character. So go from A0 mean timer, T, okay, A0. This one mean A0, okay, and then this one is A1, and this one will be A2, okay, and then this one will be A3, and then this one will be A4, okay, and so on, A4, and continue. This one will be A5. So go from A0, A1, A2, because every time the count will go plus. So every time go count, so you keep increase the counter, and then again, is the character equal null? So here is start from A0, because count is equal 0. Start from A0, is it equal null? No. Then in this case, so A count is not equal null. Yes, that's true. It's not equal null. So then count. Then A1 is not equal count null. That's true. Then go again. A2 is not equal count null. That's true. Then go again. A3 not equal null. That's true. A4 not equal null. That's true. A5 not equal null. That's not true. Then stop. Stop and then retain the count. Retain the count here. The count will be what? The number of characters. So the count will go here 1, 2, 3, 4, 5, and then stop. So the count will equal 5. So that means it will retain the count. This count will retain back to what? To here, to the len. So len will be the length of your name. So let's see this example together. Okay, so let's see this example. It's very easy. Okay, so again, one more time, I really recommend you not to copy from the slides. Do this one by yourself. But this, I don't want to make the video very long, so this is why I'm copying here. Okay, so let's check if this one is working fine. Please enter your name, Tamer, and then click to your Tamer has a length 5. Okay, let's try another example. Okay, just one more example. So Young J, then click, it will be 8, and so on. So you can try this one and play with this one as you want. Okay, so this is working fine, and this is how you can pass. So what we learned from this example, how to pass string. Okay, have to pass a string. Okay, so this is how to pass a string. Now another example is how to pass not string or array of character. How about if you pass array of numbers? Array of numbers. So this is the example here. So this example here will generate a binary sequence and count the number of ones in that sequence. So it will generate number sequence. So here, so for example, I have integer a. This is the a is some array. This is array, and this array is integer array. That means array. This will be array, and these array contents of this array will be numbers. Okay, like 3, 7, whatever. Okay, so it will be numbers. So this is array of integer, and this function. This is the function name binary. And this receive one array of integer and then also receive another number. Okay, another number, and it will retain number. Okay, it will retain number here. Okay, so now let's see what is this binary function is doing. So the binary function will say, so binary n, this is count equals 0, bin, this one bin, so this one is the array, and the array name is bin, n how much? 20. So this is mean this array is a 20 numbers array. Okay, this is 20 numbers. Okay, and then this array I will pass here, same like before in the string. I will pass it here, and then I will give n here. N is 20. Okay, so 20, and this one is the array. And then this binary will do some job. So let's go and see what this binary is doing. So the binary here is receiving the bin. So the bin will go here and then go here. Okay, this is the array. Okay, then this n will go here and go here. Okay, and then what I will do here, I will say create some random. This is for random generation. This is the random generation based on the time of the computer. So generate some random number based on the time of your computer. So your computer has a time clock. Your computer has a time clock. Okay, so based on your computer time, generate some random number. This is the meaning of this sentence. Generate some random number, and this random number, so this one will be the seed for the random number. This is we call the seed of random number. This will just help you to create a random number every time, different random number every time based on the time of your computer. So here is it. I would say for I equals 0 to I less than n. That means from I 0 until I less than 20, because n is equal to 20 here. Okay, this is a 20 from 0 to 20. Okay, every time I plus plus, that means increase I one step. Okay, that means this loop will run how many times? This loop will run 20 times from 0 to 19. That means 20 times this loop will run. Every time do what? Generate some random number, and that random number modulo 2. If the random number is even, even number modulo 2 equal 1. 0. And if the random number is odd number modulo 2 equal 1. So generate 0 or 1, and that number, whatever you generate here, I know this is a little bit you need to concentrate here. Whatever you generate here, this one will generate 1 or 0. 1 or 0. Based on the random number here. If the random number is even, it will be 0. If the random number is 1, this one calculation will be, if the random number is odd number, the total calculation will be 1. Okay? So this equation here will generate 1 or 0. 1 or 0. And then that value go to where? Go to the sequence, that means go to the array, element number, whatever I. So if I is equal to Z, that means go to the sequence array, and then in the element, based on this value, put here 0 or 1. Put 0 or 1. So maybe I will put 0, and then next element will be I will be 1. So element number, this one will be 1, and then this one will be 0, and then this one may be 0, and this one will be 0, and maybe this one is 1, this one will be 0, until 20 numbers. Okay, so that means this one here will fill the array, fill the elements of the array. Okay, elements of this array. This is array. Seek here is array. So I say whatever the value here generated from this equation, go and save it inside element II in the array. And if the element II is equal 1, if that element is equal 1, create counter and increase this counter. Okay, so this counter will increase. So that means this counter will be what? This counter will count, this one will count, okay, count number of ones in the array, How many ones in the array? Okay, in the array sequence. Okay, so in the array sequence. So how many numbers in the array sequence? So this is the meaning of this one. Okay, so let's calculate. So this one here will be the count, and here will print for you probability of ones. Probability of ones is equal the number of ones. This is retained the number of ones. So this one number of ones divide by n. So this is the probability. You know, the probability will be number of something divided by the total. Divide by total. So this one will be count number of ones over the size of the array 20. So the probability of 1 is how many ones over, or this one could be the percentage of 1. So the percentage of 1 here is 3. And maybe the percentage next time, the percentage of 1 will be different. So let's see. Let's run this one and see how this one is working. So I will, by the way, for the time here, for the time to read the time of your computer, you need the library time. Okay, so this is very important to read the time of your computer. Okay, so let's do this one, and then I will play with this example. So I will play as we go more in this example. So here is it. Okay, and I will copy this one. Okay, so here is the probability, the binary function, and then maybe, okay, let's fix this one. Okay, that's okay. Okay, so here is it ready, and then now n is equal to 20, so let's execute this one. Every time will be different, so let's see. We miss here the semicolon, so this is a semicolon missing. That means in the example, this is missing here, the semicolon. Okay, so okay, so let's run. Yeah, it's 55. Next time I run, that means 55% of the array is equal 1. So let's run 70%. You see, every time different. Okay, so run again, 50. By the way, I can even print the array contents if you want. Okay, so for example, let's print the array contents here. So I will print the array contents for you because it's simple, because it's only elements. So I will say here for, okay, I will make II from II equals 0 to II less than n. Okay, oh sorry, n, I plus plus, okay? And then I will say here what? Print, inside this one I will say print f, just print the elements of the array. I will say here, for example, modular, the elements of the array is integer, so modular digits, okay? And then I will say here, put a sequence, the array, okay, this the array seq, and print element ii, okay? So element ii all the time, print ii, and then yeah, like this. So this is the elements of the array. And then after you finish, maybe I will print here printf. Okay, so let's make here, after you finish this loop, just print at the end of the loop, just make a new line, just a new line. Okay, slash n. Okay, so I'm printing the elements of the array. So here is it, each element of the array, just print it. Okay, so let's run. Okay, let's see. Okay. Okay, so this is, there are the elements of the array digits. Okay, this one is the digits. It's printing garbage, so I need to check. Sorry, I must print this one after I fill the array. I must fill the array first. This is filling the array. After you fill the array, you print this one. This is my mistake. So before that, the array contains some garbage. It does not filled yet. So here is it. I fill it first. So this is filling. Okay, filling the array with ones and zeros. Okay, and now after the filling, you print the array. Okay, this is printing the array. Okay, now it will work fine. Okay, let's see. You see, here's the array, 20s, and if you see this one, 40%. 40% is 1. So let's see here, 1, 2, 3, 4, 5, 6, 7, 8. 8 over 20, this is 4%. Okay, so the 40%, sorry. Okay, so this is, run again, next time will be different. You see, 45%. The ones are different. Every time it will be different. Why? Because of the random. This one random. This one generates random number based on the time of my computer now. Okay, so this is how these things is working. So you need SRAM to generate random, so change the random value, and this one to read the random value. Change the random value based on the time, and this one read the random value. Okay, so two functions, but if you don't put this one, it will generate just one random value. So imagine I don't have this one. So let's see. You see, so this one, yeah, it will be same every time. Every time is same. This is not good. Okay, so every time is same, 50-50. Okay, so it will generate some random numbers, but they are same all the time. But to make them change every time you run the computer, you need this one. So every time there will be different random values. Okay, you see, every time is different. Okay, I hope this one is clear. So what we also here, how to give value for the array element, and this one how to read the value of the array elements. Okay, this is reading and this is writing. Writing because there is equal. Reading, that this is just I want to read what is the value inside this II. Okay, in the sequence II. Okay, so this is how you can so what we learned from this example, how to pass array of integers. Okay, now I will stop here in this example. Just I don't want to make the video very long, and then I will continue just more example next video. Thank you, and we'll see you in next video.